three very important royalty. The royal family is here.
I'm royal.
Presenting helium, neon, argon. Their father Xenon's not here right now. But this is the royal family. They are the noble ones of the kingdom. All right. So, here's one. Take one and pass it around. Here's one. Take one and start passing them a direction. Here's one. Take one and start passing them around. Okay? Now, I was going to tell you the story of two people, correct?
Yes. Yes. I want to go outside.
Sodium.
I think Leon. Krypton.
Here's sodium.
Kryptonite.
Guys, pass this.
And here's chlorine, correct?
Chlorine.
I have two.
Sodium and chlorine.
Yeah, that's Krypton. Is he not special?
He is.
Make them dead.
So here they are. All right? Now, sodium and chlorine were not part of the noble family, correct?
Yes.
And they were sad, right? Chlorine was always saying things like, I could be noble too. I'm not that ugly. I'm a good person. I can be noble. See, chlorine was saying things like that. And all I need to do, I'm the same as these guys. I just don't have as many electrons. I just need one more. And sodium was saying, I can be noble too. I just have one extra electron. I'm not that different. I'm a good guy. I can be noble. And the noble gases are, you'll never be like us. We are so wonderful and noble. Right?
Yep.
And so, chlorine says, what did you say, sodium? Could you say that again? And sodium says, I said I have one extra electron, and if I could just get rid of it, I could be noble. And chlorine says what?
Can you give it to me?
I need one extra electron. If you just give it to me, I can be noble.
And so even he can too.
And then he would be also, right? And so they transfer an electron. Sodium gives an electron to chlorine, right? Here she is.
So sodium chlorine is noble.
It's a ring.
It's a ring right there on her finger, right?
You made it.
Da-da-da-da-da-da-da. Now chlorine has one extra negative charge, right? So that changes this into Cl minus. And sodium lost
Na+.
an electron, so it makes Na plus.
So if they're like that, they're noble.
Like this, they're drawn together. They're drawn together and they're stuck.
Na+.
And then you have NaCl as a compound that is stable.
So it's not noble.
It's not. It never reaches nobility. They're tricking themselves. They just, they stabilize themselves a lot and they feel good about themselves, and that's all really that's important, right? Do you have a question?
No.
Okay. All right. So that's how compounds are made. You take a metal. Metals are where on the periodic table?
Well, they're
From the green
the
stage to the left.
Left of the green staircase. Everybody point the green staircase out on your neighbor's paper. On your neighbor's paper, show them the green staircase. Don't take your neighbor's paper. Just point to it so that they can see it. Where's your neighbor's paper, Brady? All right. To the left of that green staircase are the what, Emma?
Metals.
Metals. To the right of the green staircase are the non-metals. Non-metals like to do what in terms of electrons?
Transfer.
Non-metals. The non-metals like to lose or gain electrons.
Gain.
Gain electrons. How do we know that? How do we know they want to gain electrons?
Well, unless they're the noble gases.
Huh?
Unless they're the noble gases.
Those don't want to lose or gain electrons. But non-metals want to gain electrons. How do we know that?
Because they need one more to be noble.
Okay, some, like, here's a sad story, not about chlorine, but about this. Is that right? Did I draw that backwards?
What is that?
It's an S. It's Mrs. Sulfur.
Sulfur.
I wish I could be noble. I just have too many electrons. How many too many electrons does it have?
Well, she needs to gain 2.
Or sorry, I don't have enough electrons. That's right.
How do you tell how many electrons they have?
The number, because the number is the number of protons and the number of electrons
What
if it's
number?
not charged. So hydrogen has 1, the big number. Helium has 2.
Oh.
Lithium has 3.
How much do they all want?
They want to have the same as the noble gases.
Yeah. 2, 10, 18, 36, 54, 86, 118.
That's right. So sulfur wants to do how many electrons does it want to gain? 2. You see that, Tim? It wants to gain 2 electrons. Okay? So, sulfur and sodium meet, and sodium says, if I could just, what?
Lose
Lose an electron. And sulfur says, well, I need
2.
2 electrons. Right? She wants 2 rings on her finger. He says, I don't have any more to give you, sorry. But I have a cousin. Right? And so then another sodium can do what?
Marry again.
Another sodium can give another electron to that sulfur, right? And the resulting compound between sodium and sulfur to make them stable is what?
Na2C.
Na2S.
Is this used in anything?
Sodium sulfide?
Yeah.
What do you use sodium sulfide? Well, sodium sulfide, I guess, is what you would buy from the store if you were gonna use, if you just wanted sulfur as a fertilizer. I guess you use the sulfur as much for fertilizer. It'd be a good source of sodium, or sulfur. Sulfur.
Coach,
Sulfur.
Steve.
It probably would stink, yes. Although it's the sulfur solid.
I can't see how she can become noble because she's so stinky.
Aha! Stinkiness has nothing to do with nobility. All right, so
David!
you tell me what the resulting chemical formula is.
Dad, what about magnesium then?
If I take, here we go, here's magnesium, and I'm going to combine it with
Sulfur.
a chlorine. How are these going to come together to form a stable compound?
2 chlorines. Yeah, 2 chlorines.
What do you think, Couch?
Magnesium. What is magnesium? Where?
12 and 35. No, 17.
That means it's equal to 35.
So yeah, 2 chlorines.
What does magnesium need to do?
Is it magnesium?
Lose 2.
It needs to lose 2 electrons.
Gain
That's
1.
right.
Yeah. So
And
2 chlorines.
chlorine needs to do what?
Gain 1.
Gain 1.
Gain 1 electron.
Mg.
So magnesium is going to have what kind of a charge on it?
Wait, Dad. Positive.
Positive what?
Positive.
Positive 2 charge, right?
Yeah, magnesium needs
Because it needs to gain 2 or lose 2 electrons. And each chlorine
Nice
needs
try.
to gain 1. So we're going to need to have what?
2 chlorine.
2 chlorines.
So it'd be
Hold on.
MgCl2.
MgCl2. And that compound is called magnesium chloride. Very good. What's your question, Brady?
If Mg came against like a sulfur poison, where sulfur comes out of the boosted, and Mg is already in a 2 chlorine thing, would it switch or would it happen?
It depends. It depends.
Depends on what?
It depends on how they interact with each
Could
other.
2 metals mix?
Not generally. You get things called alloys, but they're not stable. Stability with alloys follows a different trend, different rules than metals and non-metals. All right?
Well, I guess you could have like a metal, then a non-metal, then a metal. You could do that.
So, Couch, I have a question for you over there.
How?
Here's the question. This is just for Couch, okay? So nobody else answers.
I didn't count.
If I have these 2 metals, Couch, here we go.
Helium.
Or I have a metal and a non-metal.
Each are.
What would the resulting compound be?
What's the Hawaii? Hi.
can't see it.
Oh, I found that bar.
Yeah, that's a bar.
I found 87. Francium. Okay.
Frankium.
Francium.
What?
Frankium. It's frankium and what
Okay,
is
Couch, how many electrons
Frankie,
does
same.
francium want to? Do you want to gain electrons or lose electrons? How many? 1. So it's going to have what kind of a charge here? Positive charge.
87 right here.
Now that confuses people. Some people see that positive sign and think, oh, plus. You must have added an electron. Electrons are negatively charged. So if you have extra electrons, you have what kind of a charge? A negative charge. If you have extra electrons, you have a negative charge.
And if you're
right?
missing them, you get
If
positive.
you're missing them, you have a net positive charge. How about fluoride? What kind of a
Wait, if
charge does
wait,
fluoride
but
get? Couch?
francium actually has an
It needs
extra.
one more, Dad.
Negative. That's right.
Wait,
Correct.
it needs one. Wait, francium has an extra. Should we know it?
Okay, that's what we just
Atoms
mentioned.
don't
That
make
it's
up
kind of
everything.
confusing sometimes to think that the
Atoms
plus
don't
sign
make up
doesn't mean
everything.
you're adding an
You know
electron.
why?
I'm saying it has.
But it doesn't make up.
No, it didn't have an extra.
Like needles.
It had the same number of protons as electrons. It just wants to have the same number of electrons as a noble gas.
Electrons are atoms.
Wait,
so the protons don't change?
So the number of protons doesn't change. If you change the number of protons, it changes the element.
it needs.
So let's draw. So the compound there that we're seeing is FRF, right? Fruff. Okay, that's what a dog says, right? Ruff, ruff. Okay,
And what time is it?
2 minutes. So this is something we need to make sure we understand. Let's draw sodium. Let's draw sodium.
Chloride.
Couch, what's the number for sodium? Emma, what's the number for sodium? Na, what's the number? Where's your periodic table?
That's not mine.
What's the number for sodium? Na.
Double one.
It's on the left.
136. 136.
Found it.
That's not my age.
It's a
11. So what does that
That'll
11
be in a
mean?
year.
11 protons and electrons.
11 protons and electrons. I'm going to draw it, Couch. Here it goes. I know you're telling me not to, but I'm going to do it anyway. Here it goes. Because I'm that kind of guy. Here it is. 11 protons. 1, 2, 3, 4, 5, 6, 7, 8. And then the rest are in the back. You can't see. 9, 10, 11. Okay? So this is the number of what?
Protons.
Protons. Positively charged things in there, right? It also has some neutrons. Neutrally charged things in there, but we're not going to draw those. And now, how many electrons does it have?
11.
11. So I'm going to draw those. So here's one orbit with 1, 2 electrons. Here's another orbit. 3, 4, 5, 6, 7, 8. And then 9, 10, 11. There's my 11 electrons. And this is what the sodium atom looks like, correct? Now, what did
So
we
it
say
actually-
sodium atom wants? Does it have a charge up here?
No.
Yes.
No, it has no charge because it has the same number of protons as it does electrons. How did we know there was 11 protons in sodium, Emma?
Because it says, what's the number?
That's the number on the periodic
Because you
table.
can look under the microscope.
And that's the same number of electrons. You can't look under the microscope for these. They're too small. It's a good question. Maybe you don't know.
Till next time.
Yeah, time's up. All right.
Wait,
The end.
we have a birthday song right here for
Oh.
this boy. Happy birthday to